Now, love it or hate it, experiencing turbulence in an aircraft is all part of flying, but British scientists have discovered that climate change could lead to bumpier flights across the North Atlantic in the next few decades, which might not be good news for the more nervous flyers amongst us. Dr. Paul Williams is lead researcher from Reading University's Department of Meteorology and joins us now. So, what exactly have you found?
Well, what we've found is that it was quite well known that climate change is not only warming the lower part of the atmosphere where we live, but it's also changing the basic state of the atmosphere 10 kilometres above our heads. And in particular, it's strengthening the jet stream. And that's what we found is that that's going to make the atmosphere more susceptible to the instability that generates clear air turbulence.
So why is climate change causing such a big difference so high up?
Well, what drives the jet stream is the temperature difference between the low latitudes and the high latitudes. And what climate change is doing is it's changing that temperature difference, strengthening it. And in response, just because of the fluid dynamics and the physics of the situation, that change is going to change the jet stream and make it flow stronger.
So how much windier is it likely to get at that level? I mean, what you're actually going to notice, for example, on a plane?
Well, the wind speeds are going to increase only by a few percent, but what we've found by examining supercomputer simulations of the jet stream is that this is going to cause the average strength of turbulence to increase by between 10 and 40% in the transatlantic sector, and for the amount of airspace containing significant turbulence to most likely to double by the middle of this century. So these are pretty worrying statistics for people who don't like flying.
They certainly are, but I suppose that 10 to 40%, there's quite a big variable there, isn't there?
There is, and that represents holes, if you like, in our understanding of the mechanisms that cause clear air turbulence. So we've calculated a couple of dozen different mathematical formulations to try to estimate the range of uncertainty. And as you say, we've come up with anywhere between 10 and 40% as being likely.
I noticed you said clear air turbulence. This isn't the kind of normal kind of bumpy turbulence. It's a bit different, isn't it?
Well, so I call it that to distinguish it from the turbulence that you would experience if you were flying through a cloud or a storm. That's obviously a bumpy experience. But there is also turbulence above clouds and storms when you're flying at cruise altitudes in clear blue skies and conditions appear to be smooth and perhaps passengers are wandering around the plane, maybe food is being served. Suddenly, you can hit turbulence even there, and the pilot can't see it coming. The electronics on board the plane can't see it either. It's invisible to human eyes and also to electronics. And this is why turbulence is particularly problematic for the aviation industry.
Yeah, actually, I was in a flight recently which had some clear air turbulence, and it's a lot more frightening than regular turbulence. It seems much more abrupt. Well,
it can cause the plane to move up and down through tens of feet. And in fact, it's not. I mean, we estimate that about 1% of the atmosphere contains significant turbulence at any one time. But that does mean that if you're on a transatlantic flight, you can expect perhaps 10 minutes of turbulence. And it does injure hundreds of passengers and crew every year. And they're almost always people who have not had their seatbelt fastened and have been flown around the plane and broken bones.
Oh, well, I don't like flying anyway. Thanks very much for putting me off even further. That's Dr. Paul Williams there from Reading University.
Yeah, these fear of flying courses, don't they? They say turbulence is uncomfortable, but it's never, ever dangerous, but it's horrible.